Hello, and thank you for joining us for today's webinar, Make Your Course More Interactive and Hands-On with Rguroo Statistical Software. My name is Danny Shapiro, and I'm on the marketing team here at Hawks Learning. Our speaker today is Dr. Mori Jamshidian of California State University, Fullerton. Dr. Jamshidian is a CNSM Distinguished Professor in the Mathematics Department, where he serves as the graduate advisor for the Master of Science in Statistics. His past positions include Associate Professor of Statistics at the University of Central Florida and Senior Statistician at BMDP Statistical Software. His area of research is broadly in computational statistics with publications in major theoretical and applied journals such as the Journal of the American Statistical Association, Journal of the Royal Statistical Society, and Psychometrica. He is currently an associate editor for the Journal of Computational and Graphical Statistics, and in the past has served as associate editor for the American Statistician, Journal of Statistical Software, and Journal of Statistical Computation and Simulation. His current activities include research in statistics education and development of statistical software for teaching statistics. We are excited that Dr. Jamshidian is here with us to share all of his expertise. If you do have questions during the webinar, please enter those into the Q&A box located on the panel, either at the top or bottom of your screen, and we will address them at the end of the talk. And on that note, I want to hand it over to our presenter.
Thank you, Danny. Good afternoon, everybody. Thank you for taking the time this afternoon to attend this webinar. So I'm going to be introducing to you Rguroo, which is a newly released statistical software. Perhaps it is appropriate to start with the story behind it and as to how did Rguroo come to be here. So about 8 years ago, I was assigned to be the coordinator for our introductory stats course at Cal State Fullerton. And at that time, we did not have a coordinator, and the course was not coordinated. So the usual thing was to start thinking about the text that we were going to use and also how we are going to run the course. Fortunately, at that time, there were GAZE guidelines. Some of you guys might be familiar with them, Guidelines for Assessment and Instructions for Statistics Education, that was published by ASA, American Statistical Association. And I looked them over, and they looked, this document is really an important document. I think it's a very useful document for whoever teaches introductory stats. And there are several recommendations in that document. And one of the recommendations is ideally students should be given numerous opportunities to analyze data with the best available technology, preferably statistics software. So at the time, we used at best calculators in our courses, and calculators, in my opinion, are not really appropriate to teach statistics, but especially that these days in our introductory courses, we are trying to emphasize concepts. So, they don't have, they're not visually appealing. You can't interact well with them. So we needed to come up with a software somehow, and I needed to think about a software that we would be using in our courses. And so before, thinking about it, I want to just say something about statistical software. So there's a statement on top of this slide that says a statistical software is not equal to software for statistics. And to explain this, let me bring in a quote from Brian Ripley, who was a professor at Oxford, professor of statistics at Oxford, a very famous statistician. So the quote goes as follows: let's not kid ourselves, our most widely used software for statistics is Excel. So notice that he called Excel software for statistics. This is surely true, but it is equally true that only a tiny minority of statisticians have a degree in statistics. We have to distinguish between statistical software and the much wider terrain of software for statistics. So that is something that that was important, that we use a statistical software in our courses. By the way, this excerpt comes from a paper written by Jan de Leo, a former chair of UCLA Statistics Department. And if you look for a statistical software overview on Google, you should be able to find that. So to begin with, I thought, well, what about R? R is a pretty powerful statistical software, and how about that? Of course, I was aware that if you want to use R, you would have to write code, and writing code is not appropriate for introductory stats students. So a thought came to my mind that we can probably write a manuscript which explains how you would do a histogram, how you would fit an analysis of variance or a regression model. And so a colleague of mine and we just wrote a manuscript that did that. And it was published by Cengage, and we started using that in our courses. Well, we failed. And in fact, we failed very badly, because what we were doing was mainly, just telling students, oh, you forgot this comma, or you didn't capitalize. And our time was really wasted on syntax, and the focus was completely taken away from actually teaching statistics. By the way, I'm also calling, I have put RStudio there because there is this misconception sometimes that RStudio is a point-and-click software for R. Well, it is only after you write your R code, then you can click to run it. And that's essentially RStudio, in technical terms, is just an IDE for R. So you do have to write code if you use RStudio. So with that, then came the thought that, I had in mind that we need to do something about the software. And it turned out that one of my good friends, who is a great software engineer, he at some point asked me, is there a project that we can do together? And after a little thought, I thought, well, maybe we can put a graphical user interface on top of R, so we can use the power of R and at the same time make it easy for people to use R. And that was about 6 years ago, and that's when we started our project. So our goals in developing Rguroo was, they were to develop an easy-to-use statistical software that moves students' focus from computing drudgery to learning statistical concepts. So students don't have to worry about how things are being computed. Let's just think about, what are the concepts there. And then there was one more thing, to conform to GAZE technology selection guidelines. So the question is, what are those guidelines? So the GAZE technology guidelines I'm going to give you in the next few slides are, the first one, ability to import data in multiple formats. So for example, in Rguroo, we can import data from Excel, from CSV files, from SAS, from SPSS, and a whole host of different formats. The ability to interact with graphs dynamically, and we can use Rguroo dialog boxes easily to interact with graphs and, for example, identify outliers or explore graphs in many different ways. Another another recommendation of GAZE was ease of reproducibility and integration with word processing and presentation software. So let me just first talk about integration with word processing and presentation software. So all of our outputs are exportable to Word. You can export them to Word. And not only that, when you export, you will get a zip file that contains the Word file. It contains a standalone HTML file. And if your output includes graph, graphs, it includes also all the graphs in that folder where you can actually, for example, put them in your PowerPoint or any other word processing function that you use. Another point, very major point, is reproducibility. So Rguroo is reproducible in two ways. So, number one, as I will explain in a minute, you can save your work at any time and come back to it. Another thing is that you can export your work as what we call RGR files, shown here. And so these RGR files, essentially whatever project you have, you just put them together, and you can share them with students or anybody else who has an Rguroo account. I'll show you an example of this at the end of this presentation here. Another recommendation, Gay's recommendation, was functional consistency across platforms, Mac, Windows, Linux, and indeed Rguroo works on any of these platforms. And in fact, it works there because Rguroo is a cloud-based statistical software. You don't need to install anything. All you need is a browser and internet. So you just go into you just open up your browser, you log into your account, and then you can go ahead and start Rguroo and work on your projects. And because it is a cloud-based software, then you can carry your data, carry your analysis anywhere that you are. And of course, underneath the engine is R, so the power of R is used for computations that are done in Rguroo. One last point that actually is not engaged, but was important to us, was that we needed to make sure that Rguroo is accessible to disabled and visually impaired. And I can claim that we have done a lot of work on this. For example, where there are software that when you look at a graph, you only see that, the voiceover only talks about gives the title, but with our graphs or our outputs, we give a lot of details. We provide a lot of details for disabled and visually impaired. All right, so let me just now go and talk about a few resources. So let me just talk about a few teaching resources. So Rguroo is set up in such a way that you can, use the dialog boxes to essentially give a live demo of your course content, and it is very useful. And hopefully it is more effective than static PowerPoint lecture notes. I will show you an example of, for example, when I teach central limit theorem at the end of this session. This particular slide that you're seeing here is just one slide from the case where I'm showing, for example, power of a test to students and teaching them power of a test. And with a few clicks, you can just show them what's a type 2 error, what is the rejection region, etc., etc. So another thing is that I believe that students should really look and read the outputs carefully. And number one, outputs should be informative and visually appealing. Also, just giving a p-value probably is not good enough. We always accompany it by graphs. So we have taken good care to make sure that our outputs are good looking. They contain good information that is understood by especially introductory stats students, and we provide them with nice tables and graphs. Again, for teaching, as I mentioned, simulation tools, I will give you an example of how you can use our simulation tools. We have pretty strong simulation tools, pretty powerful simulation tools, and that is partly thanks to R, because R is pretty powerful in doing simulations. So now as for the students, one nice thing is, because again, it's cloud-based, students can save their settings and reports at any stage and return to continue. So for example, they are in the classroom, they start work, or in a lab, they start working on a project and the time is up, they just save it and then they can go back. In fact, they can go back anywhere as long as, there is internet. They could go to their home, their coffee shop or library, and they can open up where they left off and continue working on their projects or homework or whatever they are working on. Another feature that we have are helps that is plenty everywhere. So there are question marks within each of our dialog boxes and within each section of our dialog boxes where students can get help and understand what they can do. There are these video icons where on each of our dialog boxes where students can get video help right there. And then of course we have a list of videos that they can explore by putting keywords and searching for keywords here. On the more technical side, we have a technical documentation that explains really the nitty-gritty and all the details of how we compute things. This can be useful both for instructors and students, so they know how we have computed, how we do our computations. And also within this technical documentation, there are plenty of examples that are useful as well. So a few conveniences and features. We have a data repository, which is very convenient. I will show you this in more detail, but essentially you can, in this data repository, there are thousands of data sets with their descriptions that would be useful and you can use. And also for your textbook, I will show you that with one click, you would be able to reach the data that you would need. Every one of our graphical user interface includes a basics dialog box and a detailed dialog box. And essentially, for your introductory stats courses, a basics dialog box would do, it has the basics of whatever function that they are applying. And the details, of course, you could do a lot of stuff. So if you want to, sometimes I challenge my students and I tell them, try to do this and see if you can do it and so on. And it is kind of fun sometimes to go to the details part actually and do stuff. So I'll show you this a little bit further again in my demo, in my live demo of Rguroo. So just to give you a general overview then, the statistical tools, we have data cleaning and manipulation tools. I will show you the statistical, data functions that we have in Rguroo. We have really, in terms of graphs, we have customizable plots and interactive data visualization. I mean, customization, really, if you're into customization, you can customize to very, very detail and nitty-gritty of any plot. Then we have data modeling and statistical inference. If you want to do a regression model or you want to do analysis variance, we have that, and we have a whole bunch of diagnostics and plots, et cetera, that you can use in order to model data. Finally, we have probability calculators, and they are not just calculators. If you would like, you could actually get graphs that go with whatever probability you are calculating. And the graphs are pretty informative, especially when you are teaching elementary statistics courses. They are useful. And then we have simulation suites where we do simulations. So with that, let me just pause my PowerPoint and just go ahead and go to Rguroo and start showing you a live demo of Rguroo. So you let me for a second to. All right. Bring Rguroo here. Okay, so this is the place where you actually log into Rguroo. So it's essentially just your username and your password, and you just go ahead and log in. So as soon as you log in, you'll see that there are 4 sections here. One is data, one is plots, one is analytics, and one is probability simulation. And then up here you got, your video tutorials where you can, for example, type in some sort of a keyword. Let's say if I could type in confidence interval or something, just like with confidence, you just get, videos that are for confidence interval, for example. And this is our detailed users guide, etc. And of course, settings and logout are up there. But now let me just look at the functions here. So let me just talk a little bit about data. So in the data import, you can import tables, data, or data frames, and I can just go on and talk about data by itself in a whole hour. So let me just not do that. But essentially, just to get a file from your computer, you just click choose a file, and it goes to your computer, and then you can upload a file into Rguroo, or you can actually have a URL where the data resides, and you can upload from there. And here you can see that there's a host of different data file formats that you can actually upload. So that is that. Another thing is RGR files. You can import RGR files, which I will talk about a little bit later. And then we have data editors. Now, data repository is something I talked about earlier. So let's say, for example, here I have R data sets. In fact, we have all of the R data sets and all of the R packages data sets, which is quite a few. And when you go to a data set, you can just simply click on the information, and you get information about that particular data set. And you can also search for different repositories. So for example, if you're using Hawks book, so let me just go with Hawks here. I just did Hawks. So this is, these are the data that are used in Hawks. If I just click here, then I get all of the data sets here. And for example, here, let's say beers and breweries, it has 2,396 cases. It has 10 columns. If I click on information, then I get the information about the data, the name of the variables, etc. And now let me just show you how easy it is to import this in Rguroo. If I just simply click import, notice that within less than a second, I got my data set up here. It was 2,300 some cases. So, and if I double click on it, 2,396 cases show up here. And of course, here you can just view the data in different ways. So that is the data repository. One thing that I want to bring your attention to, and it's important, is notice that some of the data sets that I have here, and by the way, you can have folders and subfolders and all of that to organize your data, but the data sets here, some of them are bold-faced and green, and some of them are not. Like the one that I just imported, it's just blue here, and it's not bold-faced. So if I just right-click on this and I say show dependencies, it says this data set has no dependencies. On the other hand, if I just go right here and I say show dependencies for this, then it tells me what I have done with this data set. For example, what I have done is I have got a subset of this data set. I have a plot, and I have analytics. And for example, if I just click on this, then I go exactly where I was, and this is what I did with the data, and I can continue working. For example, here it's saying, there were 12 in the category Asian, 14 in Hispanic, etc. And I can just simply go and modify this and say, let's just not put anything on the legend. Don't put those numbers on the legend, and just go, and you can see that they are gone. So let me say that there are other software, for example, StatsCrunch has dependencies, but all you get is just a plot. You don't know how it came about, and it is just an image. But here, what you get is actually, you get everything. Everything is reproducible, and you'll see the plots here. So let me just close this for a second. All right. So that does it for data at this point. I'll come back to this a little bit later. As for plots, we have bar plots, box plots, histogram, pie charts, scatter plots, stem and leaf. And for example, here, if I just click on histogram, so you guys can see the dialog box, you would just simply choose a data set, let me just say, choose the car data, and as soon as you choose the data set, then you get all the variables, the numerical variables that are there. And let's say I would just say miles per gallon and go, and it's as simple as that. But of course, you can work on it, add details or title, x-axis, y-axis, and a lot of different options. So again, you notice that there are details, which there are a lot of details here that you can work on, and there are the basics dialog boxes where you can just simply do just get a plot very quickly. Again, these question marks, for example, if I just click on this, I get, what do we mean by a density? What do we mean by a normal? And you get help there. And if I just click right here on the video, you can just get a video that shows you how you create a histogram. All right, so far so good. All right, so next let me go to analytics and show you the type of analyses that we can do. So you have the usual one population, two population proportion inference. You have mean inference, and I should say that in addition to the classic T and Z and all that, we also have simulation-based methods in there if you are interested in those kind of things. Linear regression, tabulating data, a goodness of fit test, and also variance, and also contingency table. These are things that we have under analytics. And then probability simulation, as I mentioned earlier, we have probability calculators, we have continuous and discrete, and pretty much every distribution that you can find in R, which is a lot, is included in these probability calculators. There is random generator that is for generating random numbers. And I will work that in a minute to give you a demo of how it works. And so I just opened it already, so let me just close this one. And then we have random selection, which is another function where you can actually do random selection from a data set, which would be useful if you're doing bootstrap or you're doing permutation tests or demoing those, or even I have used it to, for example, show how you can get data from a given probability mass function or something like that. So it's quite powerful. So I thought that to end my demo of Rguroo, to end with showing you how I would go about teaching central limit theorem to my students. And so, of course, we are going to say that, if you just sample from any population that is not necessarily normally distributed, then the sample means, if the sample size is large enough, then the distribution of the sample means is normal. So what I'm going to do is I'm going to just generate something from uniform distributions. And notice that as soon as I put uniform, the appropriate parameters show up. So I'm going to go from uniform to 6 here. All right. And again, to familiarize the student, I'm going to just go with the default. The sample size is 10, and for now, I'm going to just keep the replication as 1, and I'm going to say, okay, so let's see what happens. So I just say go, and then you can see that there are 10 numbers from 2 to randomly selected from 2 to 6. Then I say, okay, well, what is the seed for? Well, if I run this again, so remember this 3.23 I tell them, and I say if I run this again, I get the same numbers. But if I change the seed, let's say I change it to 1,000, then I'm going to get different numbers, right? So I guess there is a little bit of explanation to do about the seed, which you can do in your courses. Another thing that needs explanation is probably replication. So what does the replication do? So I'm saying take a sample of size 10 from uniform to 6 and replicate, let's say, 2 times. So let's do that. And so here now I have sample 1 and sample 2. So I replicated the sample. And at this stage, I'm going to tell them, let's look at sample 1 and see what is the smallest number that you see in sample 1. And hopefully they come up with this fourth case, which is 2.22. And then I ask them, oh, what is the smallest number in sample 2? And hopefully they come up with this one, which is 2.814. And the reason that I'm doing this is because I want to show them what is the utility of this statistic. So here in this statistics dialog box, you could actually compute different statistics, in particular the minimum. So if I just go ahead and use the minimum here, just choose the minimum, then I'm going to just click. And sure enough, for sample 1, it computed minimum of 2.22, and for sample 2, it computed a minimum of 2.81. So I explained to them, so what happened now is we took a sample of size 10 from uniform 2 to 6 and replicated it 2 times and computed the minimum for each of these samples. That's what happened. By the way, for those of you who are a little bit more advanced and you want to do more advanced stuff, there's custom statistic here that you can actually write your own custom statistic using the R language. So now, of course, we are talking about the mean. So can I get the mean for the same data? So I'm going to just go ahead and use the mean here. And when I do that, not only I get the minimum for each of my samples, I also get the mean of each of the samples. All right. So right now at this stage, I'm hoping, of course, I go probably a little bit slower with the students, giving them more examples. But for this audience, I think I don't need to do that. So at this point now, hopefully they are familiar with this random generation and what it does. Now, I'm going to say, okay, let's see what a random sample from uniform looks like. So let's just go back to our, one replication. And instead of 10, let's just replicate 10,000 samples from the uniform. So I'm going to just say go. Sorry about that. I'm computing. Let me just, for a second, not compute the minimum and the mean. And let me just say go. Okay, so right here, you can see that quickly I got 10,000 samples. If you can see at the bottom here, it says 10,000, 1 to 10,000. So I have 10,000 here. So what I want to do is I want to show them what a sample from a uniform distribution looks like. All right, so I notice here I want to save this data, but notice there are 2 save as here. One is, if I let me just write uniform 2,6 here and say save as. Notice that this showed up here. What this is doing is essentially saving everything that is in this dialog box. So if I, for example, just close this or log out, come back, and double click this, it just comes back to me, right? That's what that save as does. But what I want to do is I want to save this data set actually and as a data and try to graph it and so on. So let me just also, you don't have to call it the same name, but let me call it the same name. Uniform 2,6, let's say, and say, oops, sorry, I think I misspelled. I'm going to say save data. Now it says data set uniform 2,6 saved as an Rguroo data set. So if you just go back to data now, you see that this uniform 2,6 is here. And in fact, not only it's here, it will appear in every one of the dialog boxes that we open. Another feature is, suppose that you have a lot of data sets here and you don't want to just show them all. So I can just filter them. So I'm going to just filter this so I don't see all of these in my menus when I open them. So I'm going to just say uniform. And so from this point on, every time that I open a menu, I'm going to just see this particular data set. So let's go to the plots here. And I'm going to create a histogram out of this. All right, so I'm going to go to the histogram and, well, I have to have a data set. So I'm going to select the data set. Notice that only uniform shows up here because I filtered it. If I had not filtered it, you would have seen all of the data sets that you had available. So it's uniform. And here I can just go ahead and use sample 1. Why sample 1? Remember, our data, in fact, I can just show you as a data set. If I just double click on this data, set, you see that sample 1 is our data set, right? Our variable name. So let me, and it shows up here. I'm going to say, do this, sample 1, and I'm going to just say go. And, you know, this is as best as you can get in uniform. Of course, if you like, you can actually draw the density if you like. And not only that, maybe you can put a density curve, which is a smoothed version of the histogram on top of it. And of course, you know, you expect a flat line here, but that's the smoothed version that Rguroo calculates. Of course, let me also say, for those of you who know about advanced stuff about smoothing, you can actually, there are lots of parameters with, related to this screen curve that you can set if you wish. So now I tell them, okay, so this is the distribution. This obviously doesn't look normal. And let's go and try to sample from this distribution and, you know, compute the sample mean and see what the distribution of it is. Also, you know, you need to point out that, you know, the numbers are from 2 to 6 and so on. So they understand that this is from uniform 2 to 6. Okay. So let's go back to our probability simulation. I can go ahead and continue working here, but for a reason that I will tell you in a minute, I'm going to just open a new random generator. Okay. So again, so what did we do? We said, okay, so we want to generate from uniform with minimum of 2, maximum of 6. And, you know, we always say sample size 25 is big, so let's try a sample of size 25. I always do the replication once. So here it is. So I have now a sample of size 25 from uniform 2 to 6. Then remember, we need to compute our statistic. And let me just continue computing the minimum as well as the mean. So if I just do that for this sample, you're going to see that, you know, I get the minimum of this sample size 25 and the mean of the sample of size 25. So with that, let's just try like replicating 5 times and see what we get. You know, here we go. We have these 5 different samples, and I explained to the students, in each case, a sample of size 25 is taken, its minimum is computed, and its mean is computed. Then, of course, in order to show them the distribution of the minimum or the mean here, which is our major goal, I need to replicate a large number of times. I'm going to replicate 10,000 times. As you see, there was a lot of computation, but it takes only a couple of seconds, and now you got your 10,000 replications. Okay. So I'm going to save what I did as CLT 25, central limit theorem 25. And I'm going to also save my date. So let me just do that so I don't forget. So it says saved successfully. And I'm going to save my data set also as CLT 25. All right. So my work is here in case I close and come back to it. And now my data hopefully is there, and CLT 25 short is there. So let's go to histogram again, and I'm going to create a new histogram. I could again go to the back to the old one, but I want to keep that. So when I go here now, the newly formed data set is here, which is CLT 25. I'm going to select it. And when I look at the variables, notice that there is both the minimum and the mean, right? And of course, for the central limit theorem, we are interested in looking at the distribution of the mean. So I'm going to just select the mean here. And I'm going to say, go. All right, so it looks good. Hopefully, the students recognize this histogram having a bell-shaped distribution. And so what I would do is perhaps let's just, you know, put a density curve on it. And, you know, this density curve, I usually familiarize them with the density curve you know, when I talk about histograms early on in the course. So they understand what it is. It's just a smoothed version of the histogram. So does it look like normal? Well, maybe. Let's try now to put actually a normal curve also on it. So here in the smoothing, I could either put a density curve or a normal. So let's do that. And now the red is normal, and the green is the smoothed version of the histogram. And maybe the bars are on the way. Let's maybe compare these two graphs, maybe we can get rid of the bars. And these are some of the things that you can do in details. So for example, if I go to details, there are lots of stuff that I can do about bins and bars and etc. But right here, I can tell it to hide the bars. Okay, so now the students can see it better. And, hopefully they accept that this is, approximately normally distributed. Well, then I say, well, what do you guys think? You think the minimum is also would have a normal distribution? And we just go into a discussion, etc. But let me just show you what happens when I do this. So I'm going to say, okay, show me now the distribution of the minimum as compared to normal. And when I say go, then well, that green guy is the histogram for the minimum, but the red guy is normal. And some students tell me, oh, but this doesn't look like, a normal distribution there. And that's essentially because of obviously the scale on the x-axis. And that's an easy fix. Again, in the details, if I just go to title and axes and go to the x-axis, lots of things you can do here, but I want to just change the axis limits. Let's say from 1.8, I don't know, I'm just guessing, to 2.8 here. Yeah, I think it worked out okay. Maybe I should have gone a little bit further back, maybe 1.6, let's say. I'm just in 1.6. Yeah, and it's obvious that the distribution of the minimum is not the same as it is not normal. And, just to make sure that they believe that this really is the histogram, maybe I'll just go to my bins and bars and just show them the histogram. And so they can see that actually the histogram, this is the distribution of the minimum and it's not normal. So with that now, by the way, one thing I want you to note is that you see that these are, the uniform 2.6 is in green, the CLT 25 is in green, but histogram 2 and histogram 4 are not in green. And by the way, whatever you want to call it here, if I save it now, it will save with what I spelled, whatever you want to put here. I put mini, comma, u. So it shows up here. So things that are not saved are going to be in red. Now, with that, the next thing I want to show you is I want to go back here. And at this stage, I'm done teaching essentially the uniform, the central limit theorem. Now I want to share what I have with my students. So what I'm going to do here is I'm going to open a folder. So I right click here and I say add a new folder. And let's call it central limit theorem or something. Central limit theorem. Okay. Now I can copy. So remember, these are the two things that I actually use. These are the dialog boxes that are saved here, right? Here and here. So I want to share these with them. So I'm going to just either I can copy them into this folder, or I can just go ahead and move them to this folder by just dragging them. Then what I'm going to do is I will right click on this and I'm going to say export as RGR. Okay. So as soon as I say export as RGR, it will actually want to save an RGR file on my, I'm going to just choose the desktop so it's easier to share with you, on my desktop, and I'm going to say save. Okay. So this now saved my RGR file on the desktop, and notice it is sitting right here. It's a central limit theorem right here, right? Okay, now this is something that I would put on Moodle or whatever you're using to share files with the students. And what students can do now is, they can go log into their accounts, and let's go back again to this data, and you could say import RGR and choose file, right? And I'm going to go to my desktop here, and this was the central limit theorem, RGR. I'm going to say open, and I'm going to say upload. All right. It says archive file central limit theorem RGR imported successfully. And now what you see here is, let me just get this out. You can see here that if I open this, I have this same structure in the original, right? In fact, if you have many folders within folders, you're going to get the same structure, right? And you can, in fact, move it out of here if you want. Let me just because I cannot have the same names, let me just rename this here. Let me call it a 1 or something. And I'm going to just move it out. So I don't have to have this. Let me just delete this. Okay. So it is here. And if you just double click, sure enough, you're where you are here, what you have here, and what you have here. And for example, you can tell the students, okay, now try a sample of size 2 and see what happens, or try it different. Like for example, the fun thing would be to look at the median, distribution of the median, etc. So this was a demo of, a live demo of Rguroo that I wanted to share with you. So let me just go back to the PowerPoint now. So training, pricing, and purchasing, we do provide one-on-one training for faculty. If you're local, we can even come to you, and otherwise we would use some sort of an online system to do it. We also would provide workshops free for your colleagues in a group if you want a workshop for a group of your colleagues or for your department. As far as pricing is concerned, all instructors, whether they actually adopt it for their course or not, they can get immediate and complimentary access. And for students, it is a $20 12-month subscription fee. And for purchasing, your bookstores can order it, and you could also purchase it directly from the Rguroo website, or you can order it through Hawks, and those are the information given on this slide. So I'm going to stop and give it to Danny at this point.
Okay, thank you so much for that presentation. I want to remind our audience that they can ask questions in the question and answer box. And again, you can find that at the top or bottom of your screen. Before we get into some questions, I see some of those already coming through. I do want to launch a quick poll. We would love to do another webinar in the future, and we would like to see what you as the audience might be interested in seeing even more in depth. So as we wait for some more questions come in, I'm going to launch that poll. You should see it up on your screen now. And please take a minute to answer that, and we'll go from there. Thank you so much for everyone who voted. I will share the results here for a minute so that you can take a look at what your colleagues were interested in as well. And we will use this data as well as the additional feedback to schedule some future webinars to provide more in-depth information about Rguroo. So Dr. Jamshidian, I want to jump into questions. We have a question here. At the beginning of your talk, you mentioned that using R and RStudio was a failure in the classroom. In what ways has Rguroo been more successful? For example, did students respond positively to this software? And Dr. Jamshidian, if you can please unmute your mic there for a second.
All right, can you hear me now?
Yes, I can.
Yeah, okay. We released our Rguroo actually just this past August. But it has been used at Cal State Fullerton and a couple of other colleges in the past 3 years actually as a beta, and we have received many positive feedback, and students have a lot of fun using it because the learning curve is pretty flat. It's very easy to learn, and also the faculty have been very happy with it. In fact, I can tell you that I'm no longer the coordinator for our Math 120, and I'm not even the coordinator for another course, which is Math 338, so our Math 120 is mostly psychologists and social sciences, and our Math 338 consists of some computer scientists, some from biology, and actually natural sciences. Our faculty have also adopted it for both of these courses. Math 338 is a GE for natural sciences and as well as computer science. The fact that the faculty are not going back to anything else, or the students have given us a very positive feedback, I think speaks for itself. As I said, R was really something that we had a lot of difficulty with, but because our Rguroo's user interface is fairly simple to use, it has been very useful in our classrooms.
And we have another question asking, are there Bayesian statistics in our Rguroo?
Interesting you ask. Not quite, but if you're a Bayesian, I can tell you that we have Bayes factor bounds, which is in a recent article in American Statistician. It was mentioned by James Rguroo. And for example, if you go to our proportion inference, in addition to p-values, we report Bayes factor bounds, and we are actually going to be doing this throughout our Rguroo. That is, wherever we have a p-value, we are going to add Bayes factor bounds. So that is as close as we get to Bayes, but at this point we don't. But certainly in the future, we are thinking about expanding to that area.
Thank you. And another question. Do you have any suggestions for how our Rguroo could potentially be used in an intro math course, not necessarily an intro to statistics course?
So it really depends on the topic that you're teaching. Let me just say that in terms of graphs, you can actually, any of these graphs that you have, you can actually draw functions like sine of x or what have you on top of the graphs that you generate. Also, we have like transform function where you can write R code to compute things. It really was not designed, for example, to be used for a calculus course or a college algebra course.
All right, thank you. I see that we are getting close to the end of our time. I want to remind our audience that if you don't think of a question today, always please feel free to email it to us at marketing@hawkslearning.com, and we will get back to you with an answer, or have Dr. Jamshidian get back to you with an answer. I want to thank everybody for their time today, and thank Dr. Jamshidian again for the presentation. We will be emailing out a link to view this webinar on demand within a few days. If we have no other questions, then I want to wish everyone a great rest of their day and a great weekend.
I also want to thank everybody on behalf of the Rguroo team for participating in this webinar, and have a great day.
We did have one more last-minute question come in, which I think is great to address. I think you talked about this in the PowerPoint, but of course we have people come and go. So the question is, do you have to have R installed on the computer you're using to use Rguroo?
Not at all. You don't need anything at all. No installation of any software is required. All you need is a browser and internet. And so you would just log in, and you do not need to have R at all. You don't install anything with Rguroo. Yeah. That was a good question. You don't have any kind of installation. All you need is a browser, and that will do.
Okay, thanks again, and have a great weekend. Bye.
All right. Everybody have a great weekend. Bye.